Good evening. I'm Ellen Treppe from the Office of Alumni Relations at Thomas Jefferson University, and I'm happy to welcome you to tonight's program where we'll learn about the chemistry of my favorite beverage, coffee. Throughout tonight's talk, I invite you to share any questions that you have using the Q&A button located at the bottom of your screen. We will address questions at the end of the presentation as time allows. If you do not see the button, try moving your cursor and it should appear. Before we get started, I'd like to say a special thank you to Ninth Street Coffee and Tea Company for their help in providing our coffee samples. I hope you've enjoyed the coffee as much as I did. And now it is my pleasure to introduce tonight's speaker, Dr. Niny Rao. Dr. Rao is an associate professor of chemistry and the director of Chemistry and Biochemistry Program at Thomas Jefferson University College of Life Sciences. She received her bachelor's degree in chemical engineering from the Cooper Union and went on to pursue a PhD in physical chemistry at Florida State University. A computational chemist by training, her past research interest spans from small inorganic ion clusters to protein-lipid bilayer complex. As an enthusiast of artisanal food and beverages, Dr. Rao has expanded her research into the field of food science. Dr. Rao, thank you for joining us this evening. The floor is yours.
Good evening, everybody. Thank you so much for joining me. As Ellen said, I'm Niny. I am Associate Professor of Chemistry here at Thomas Jefferson University. I'm based in the East Falls, and I'm also the Program Director for the Chemistry and Biochemistry Program. So today, as you have seen, we're going to talk a little bit about chemistry in your cup, chemistry of coffee. So do you know that last year in 2020, the United States actually consumed 3.5 billion pounds of coffee, and we are actually not number one. We are the second largest importer of coffee. Number one is European Union. And in terms of consumption, we are talking about Finland take the king in terms of per capita consumption. And in Finland, each person can consume on average about 27 pounds of coffee per year. Our northern neighbor, Canada, and they consume about 15 pounds of coffee per year, and they are ranked about number 10 in the world. And we consume about 10 pounds per person, and we are about number 18 in the world. So we're not the biggest consumer of coffee at all. So to talk about the cold coffee journey, we have to start talking about how coffee is grown. Coffee is not grown everywhere. And as a matter of fact, it is only grown what we call a coffee belt. It is said to be in around the equator. And within that region, we have some of the biggest coffee exporters, Brazil, Colombia, and Ethiopia. And in United States, the only region that has established coffee plantation is in Hawaii, on the big islands and Kona region. As Kona coffee is what it's famous for. Brazil is the number one exporter of coffee in the world, and number two exporter of coffee in the world is actually not Colombia. Colombia is number 3. The second one is actually Vietnam. So why? Well, turns out we also have to talk a little bit about the species that we are consuming. Coffee, if you're not familiar with the plant itself, actually produces what we call a cherry. So it's a fruit. And you have to remove the hulls and you remove the pulp to get to the seed. And that's what coffee bean really is. And there are two main species of coffee that we consume. First one is Arabica. It is grown in very high altitudes, cooler climates, very high maintenance, but much better flavor. So it fetches higher price. But because it develops flavor, it has less caffeine and less chlorogenic acid, which is an antioxidant. And Arabica coffee actually accounts for about 75% of the world production. Brazil is the number one producer of Arabica coffee. The other species that we encounter a lot is called Robusta. It is produced at a lower altitude and warmer climates. Doesn't taste great. It tastes like burnt rubber, according to some people, but it does have a higher caffeine content, and it is very often used for instant coffee, and it counts for about quarter of the world production. Vietnam is the number one product. Produces the most robusta coffee in the world. So that's the coffee bean. That's the plant that we are consuming, the seed of the plant. And the next step after you have harvested the beans, you are actually going to process it by removing the pulp, dry the beans, and then sort the beans, and then package it for export. All of these steps are actually done by hand. Some some coffee plantations actually sort their double or triple sort their beans by hand. So coffee bean production actually is quite labor intensive, especially in some of the quote unquote high end coffee beans. After export, beans get to its destination and then it has to be processed. This is where roasting and decaffeination comes in. So I've got a lot of questions before about decaffeination process. Decaffeination basically is a process to remove caffeine from the beans. It is usually done with a solvent. Now in the world, most common decaffeination process involve either a chemical solvent or liquefied carbon dioxide or water. And each method has its pros and cons, and they are all highly efficient. For example, if for the solvent decaffeination process, we typically use a chemical solvent called dichloromethane or ethyl acetate. And you use about 10 kilograms of the solvent per 1 metric ton of coffee. And by the time you finish washing the solvents away, you only left with less than 1 milligrams of solvent per kilograms of coffee. So they are highly efficient, and this process can be done in 3 to 5 hours. And this is before you roast the beans. So once you decaf the coffee, you can start thinking about roasting the beans. So roasting is basically cooking the beans from green bean, a waxy green bean, to something nice, beautifully brown and flavorful. Depend on how much heat and how long you roast it. Obviously, you will reach different color stage from light, medium to dark. The tip, if you talk to a lot of roasters, you will hear the word crack. So that refers to when you're roasting coffee, you actually hear the coffee cracking twice. The first crack is due to water expanding and then basically exploding the beans into increase the volume of the beans and double the size of the beans. That's the first crack. It's really loud. It sounds like popcorn. The second one is due to the increased heat and the collapse of the cellulose in the structure. It's much softer sound, but it is indicative. So a lot of roasters use the sound to judge when the beans are done. And French roast typically is the darkest, and other roasts, depend on what you like, you can adjust the roasting degree from very blonde to light roast to medium. So after you roast the beans, the next step would be grinding and brewing. So grinding and brewing goes hand in hand. You choose a grind size to brew a specific style of coffee. If you are trying to brew Turkish coffee, you will use a grind that's powdery, very, very fine. Whereas if you are talking about cold brew or French press, you will use a grind that's much more coarse. So the brewing methods dictates the grind size, and this is, at the same time, the grind size also dictates how much flavor and how much chemical you can extract from the coffee grind. So they go hand in hand. So what do I study? Well, I study cold brew coffee. if you go to the market nowadays, you can see plenty of bottled cold brew coffee. And if you do some search on the internet, you'll find that, oh, you can make a cold brew coffee in a mason jar. Or if you really want to be adventurous, you can do what we call a cold drip coffee, which looks like a synthetic experiments that we would conduct in our labs. So all of these are basically coffee brewed using cold water. So if the recipes we use requires about 1 gram of coffee to 10 grams of water and at room temperature, and then we let it seep for about 12 to 24 hours. It was very popular. It started in the early 70s, but it gained popularity in the last decade, and it has a huge market. But it turns out that there's not that many research done on cold brew coffee. There are a lot of research on coffee in general, but not so much on cold brew coffee. So vendors tend to sell the cold brew coffee as less acidic or more caffeinated or smooth and full-bodied and sweet. But really, we don't know exactly they are true or not at the time, and we don't know whether what these words mean in general. So that's how I started. I went to a conference in 2016 in San Diego, and I had a cold brew coffee. And I was like, okay, I can do this. I think I could make it myself because you can make it in the mason jar. And turns out it's not that simple. So I convinced my collaborator at the time, Dr. Megan Fuller, to join me on this journey discovering cold brew coffee. And the last 5, 6 years, we've learned a lot about coffee in general, and then we learned a lot about the extraction method itself as well. So what do? We actually studied the extraction method rather than the coffee itself. So we wanted to answer the question we wanted to answer is how is cold brew extraction differ from a hot water extraction? So we look at how fast chemicals are coming out, the kinetics of extraction, how much they're coming out. We're focusing on 2 compounds, caffeine being one of them. Everybody wants to know what caffeine's like. And we also look at chlorogenic acid, which is antioxidant. And then we wanted to answer the question, is it really true that cold brew coffee has lower acidity than hot brew coffee? So we measured the pH, which is an indicator of acidity. We also looked at what we call total titratable acids. So this is a measure that gives us a total quantity of how much acid in a solution. And then antioxidant, since we're looking at chlorogenic acid, antioxidant would be something that we want to look into because chlorogenic acid is part of the antioxidant component in coffee. And the last we got, after 3 years of playing around in the lab with brewed coffee, we became very adventurous. So we decided, you know what, we're going to roast our own coffee. So the last project we did, we roasted coffee, and then we want to see if cold brew coffee, cold brew method changes if you use different degrees of roast. How does the output different if you use different roast using the cold brew method? So in the beginning, we didn't know better. We went to the store and we bought coffee off the shelf, pre-ground and pre-roasted, and we picked larger grind size, medium and coarse, just because we didn't know better. We really didn't know much about how to do coffee research, and found a recipe on New York Times and 1:10 ratio between grind and water. And we use a French press method because it's almost the same as the cold brew method, the mason jar method. So we brew the hot brew 6 minutes at 100 degrees Celsius. Don't do that for French press. And then we use 22-degree water for cold brew. So that's our first experiment. And what we found is that for the cold brew coffee, most of the recipes ask you to brew the coffee for about 12 to 24 hours. Some barista actually told me that they brew their coffee for 48 hours. if we were just monitoring caffeine concentration and chlorogenic acid concentration, we can probably get away with brewing the coffee for about 7 hours. So that means we can actually make the coffee before we go to bed, and next morning we have a nice freshly brewed cold brew coffee. So that was very exciting because that shortens the brewing time from 12 to 24 hours to 7 hours. And the other thing we were trying to do, and it wasn't very clear to us at the time, was we trying to differentiate roast as well as grind and how these two variables impact the final outcome of the coffee brew. And it wasn't very clear to us. And we thought about it and we figured out why. Because coffee grind is not uniform. When you purchase a bag of pre-ground coffee, there are different size particles in there. So the main portion of the coffee grind is, let's say, medium. In our case, we have about 400 microns as our average size, where majority of the size was in that range. If we're talking about coarse grind coffee, at least the one we bought, the particle size, 75% of the particles are in about 840 micron range. So the size is not uniform. They are different. And then there are always the fine particles. They call it in industry, they call it the fines. They are always present in no matter which grind that you're using. And brewing is extraction. So the process basically is that you are removing chemicals from a solid phase to a liquid phase using a solvent. In our case, it's water. And if you have a different size grind, you have a different amount of chemicals within the grind. And if you decrease the particle size, you actually increase the extraction efficiency because the water has an easier time passing through the grind and take the chemicals away from the solid phase. So those finer particles actually kind of muddling with our results a little bit. So we weren't able to get a clear understanding of how particle size and roast were impacting our final brew. Here's a few more interesting things that you may want to know. Number one is fines are not desirable in a lot of the brewing procedure, especially French press, because they're the one who tend to escape the plunger, because the plunger only go up to, usually it's about 72, 73, maybe 100 micron size, and it doesn't stop the fines. And then if you have a lot of smaller particles, you tend to have what we call over extraction. So bitter compounds, and then like it or not, they tend to come out of the particles more readily, and you end up with coffee that's a little bit more pungent. And French press is not my favorite brewing method. So we learned that. We now know that we should eliminate the finer grinds in our future research, and then that's exactly what we did. So the second one, we again went to the store, bought coffee off the shelf. This time is a lighter roast, and we bought it from coffee from around the world, and we sieved it. We only retained a small portion of the coffee grind. It's about 400 microns up. And we tested the acidity and of the coffee between hot and cold. And this is what we found. The pH for this case is about the same between hot and cold. But if you look at total acidity, cold brew coffee has lower acidity than hot brew coffee. What does that mean? This tells us that there are chemicals, acids in coffee that are not soluble at low water temperature. So at higher temperature, it allows the acids to be released because it's soluble in high temperature. But at lower temperature, these compounds stays in the coffee grind. So that was interesting. So vendors were correct. Cold brew coffee has lower acidity than hot brew coffee. And then we looked into antioxidant. hot brew coffee definitely has higher antioxidant than cold brew coffee. Not only that, we also notice an interesting correlation. So we trying to correlate the antioxidant activity versus the CQA, the chlorogenic acid concentration. So we found that for cold brew coffee, we have a very strong correlation between antioxidant and chlorogenic acid concentration. So what this tells us is that the majority of antioxidant activity in cold brew comes from chlorogenic acid. This is not the case for hot brew. So in hot brew, the high water temperature actually draws out more antioxidant than in a cold brew. And then these antioxidants are not soluble at lower temperature. So the chemistry of a hot brew coffee actually is quite complex. So at this point, we were like, great, we learned a lot about coffee. We actually learned how to brew coffee, and we can say a lot more about how cold brew coffee is made and then how it compared to a hot brew method that's comparable. So we got very adventurous. We were like, okay, let's roast our own coffee. So we want to see how roast different roasts affect the brewing process. Because we know that when you apply heat, you are actually destroying some of the compounds, and then you're also creating others. And would it be different? So in hot brew coffee, people tell you like, oh, you have medium, you have dark, you drink different roast if you want different things. And then would it be the same for cold brew? That's the question we wanted to answer. So we bought a roaster, tabletop roaster, and we had fun. We got some organic Colombian beans and we roasted our own. We did it 3 different roasts. We did the first one, we stopped it at the first crack, meaning it's probably a lighter roast. Medium, a second one we did after the second crack, which is considered medium dark, depending on which roaster you talk to. And then the third one, we did it. Basically, we made the our roaster auto eject, so it's right before it becomes a fire hazard. So it's really dark. And then we grind it, sieved it, making sure we create as uniform grind size as possible, removing some of the fines that is not desirable. And then we brewed it exactly the way we did it before. So this is what we did. As you can see in the middle picture, we have different colors of coffee. We had a roaster. We were having fun. We did some really light roast and also very dark roast. The last 3 are the ones we analyzed. And we measured the pH. We also measured the total acidity. So this is really clear now that cold brew coffee has lower acidity than hot brew coffee. Not only that, if you increase the roast, so light roast versus dark roast, the darker the roast, the lower acidity. This is true for total titratable acids as well. Not only that, you see that the difference between hot and cold gets larger as the degree of roast increase. Because again, when you're creating more compounds during the roast, very often these compounds are not soluble in water, in cold water. So you have less acids, and then not a lot of them are not soluble in water. So you end up with like less extraction. So vendors were correct. Cold brew coffee has a lower acidity than hot brew coffee. And then we look at everybody's favorite question, caffeine. Caffeine is known to be thermally stable. So a lot of people ask me, so which one should I drink? Light roast or dark roast for most caffeine? They are not that different. Caffeine does not degrade as much during the roasting process. There are a lot of literatures have reported that. And we saw the same thing. And not only that, the cold brew and hot brew coffee tend to have comparable caffeine concentration. So nothing really interesting here. If you want to drink something that's highly caffeinated, it's more important to put more coffee grind in there than to choose the roast. It's my opinion. And then the last thing we looked at is chlorogenic acid concentration, because again, it's antioxidant, right? And this time, we know that chlorogenic acid should be soluble at all temperature, and they are. So we also know that it degrades as you apply heat, and it did. And then you see that clearly as you increase the roast, and the concentration of chlorogenic acid drops. But hot and cold, there's no difference at all. But total antioxidant changed. The hot brew coffee has about the same total antioxidant regardless the roast. Whereas the cold brew coffee, the antioxidant level, number one, is always lower than hot brew. Number two, it drops as you increase the roast. So when we dig into the literature, some of the previous studies have reported you actually, while you degrade some compounds, you generate others. Very often, these compounds are antioxidants, and these newly generated compounds are not soluble in cold water. So you have these antioxidants not being extracted in cold water, but it is extracted at hot water. So the moral of the story, if you are looking to drink a beverage that is low in acidity, maybe you want to consider a dark roast cold brew. If you're looking to drink coffee for its antioxidant activity, probably a hot brew would be your best bet. So this is my research, and I could never done this research that I've done without the help of a group of amazing undergraduate research students. They're dedicated, they're smart, and they're hardworking. And almost all of them have graduated, and we have a new group joining us starting next semester. So I'm very excited to work with them. And I also just want to thank funding agencies, and especially Elaine Martinson for her generous donation for the Undergraduate Capstone Experience Fund. Without that, we couldn't send our students to conferences and then presentations. So that was always very helpful for us. And thank you very much for joining me, and I'd be happy to answer any questions that you may have.
Wonderful. Thank you so much, Dr. Rao. And I'm glad that we left time for questions because we have some questions. So I'm going to start with a few of the questions that came in on the registration process, and then we'll move over to some of our in the moment questions.
Absolutely.
Lots of minds want to know what is the best way to store coffee to maintain freshness?
The best way to store coffee, in my opinion, is to freeze it. Regardless being whole bean or ground, you should freeze the coffee. There are a couple reasons for that. Number one is if you have a whole bean coffee, you freeze it. When you take it out of the freezer directly and grind it, it actually gives you a more uniform particle size. Very recent, like 2 years ago, a group in California did a study on that, and they published the result. It was like from that point forward, everything I do is freeze the beans before we grind it. That's number one. Number two is from a perspective of volatile organic. They're volatile, so high temperature will cause them to release into the air. And if you freeze them, they tend to stay fresh a little bit longer. But if you talk to any roaster, they also would tell you don't store your coffee for too long. So buy just enough, enjoy it, and then try something new.
Wonderful. So how do you select or spot quality beans or brands versus just a high price, making you think you're getting a good purchase?
Well, I like to talk to roasters. I like to talk to them about what they look for in terms of quality. Very often they look at the beans flavor and where they're grown. And a lot of the smaller coffee roasters that I talk to, they tend to source beans more responsibly than bigger coffee chain. And then, that's how so basically they would tell me honestly, oh, if you like, they'll ask you what you like, whether you like something a little bit more fruity or a little bit more earthy, and they will recommend something for you. And then try it, and then if you like it, continue to purchase it, and if not, try something different. But I think the best way to do that is actually talk to the roaster. It's really hard if you go to the grocery store, I know, but if you have the opportunity to go to a roaster, independently owned roaster, it's definitely something to do.
Great. So we have two questions that have come in live tonight, sort of around the oiliness of some beans. So the first one that came in, I'll ask it this way. I seem to notice that beans from many smaller craft or artisanal roasters are mostly dry and almost dusty, while beans from some larger commercial type roasters seem to be oily and slippery to the touch. Am I off base, or is there something to this? And then the following question that came in after that is, what is the oil on the surface of the bean, chemistry-wise? Or does it contribute to the chemistry?
So there is a percentage of fat or oil in beans to begin with. If you take a look at the green beans itself, it's actually very waxy. So it's all lipids. And then as you roast, these lipids and react, and some of them will actually come to the surface because the surface structure becomes gets disrupted, and then you have that oil. You have that oil sheen more exposed to the surface, and that's especially true if you roast the beans for a long period of time, and that's what the dark roast would be. The lighter roast, because you don't expose the beans to that much heat, and very often the lipids are still in the buried in the beans itself, so you don't have that oily sheet. And you also have to one of the things about oil in coffee is how you brew it as well. Very often, if you boil the coffee, you actually extract more oil into the coffee brew, other compared to some pour overs where very often the oils are in the surface and then not going into the brew itself.
So this is a question I think that crosses across many fields of food. What exactly makes something organic? So when we say that the beans are organic, what does that mean?
Different um, different fields have different answers to the word organic. Usually in agriculture, what they're referring to is the way that crop was attended. So when they say organic, they mean that they don't use, not that they don't use pesticides, they don't use certain pesticides. And unfortunately, some of the pesticides, even for organic organic growing methods, they are still harmful to some other to pests because they are pesticides. They kill bugs. So it is a but without pesticides, very often the yields are not going to be good because it's a cash crop. People want to basically make money off of it. So it is important to kind of talk to the roaster, see how they choose their grower. Most of them have a very good relationship, and then they even tell you they've been to the farm, they've seen where the beans are grown and how they attend it, and it's the best way to learn about coffee as well.
So here's the question about sort of trying to get the best of both worlds. So if someone doesn't like cold coffee, can they heat cold brew and receive the antioxidants properties and low acid properties?
Aha. Cold brew coffee. I have to confess that I am not a cold brew fan. Even though I studied it, I tried it, I make it, and I prefer a good old pour over. But the problem with antioxidant is that the low acidity part, yes, you can heat up the coffee and still receive the low acidity. The antioxidant part of it, unfortunately, is not going to be the case because once you extract the antioxidant, you discard the grind, it's gone. You cannot get the rest of them from the grind. So when you heat up, even if you heat up a cold brew coffee, you are actually still retaining the antioxidant concentration of when it finished brewing, rather than being a hot brew where you get all the stuff out of the coffee grind.
Excellent. So one of our attendees read that using a French press to make coffee produces an extraction of chemicals that may not be healthy and could possibly be toxic. Have you read the same thing? Do you have any comments about that?
Um, I have not read that the same thing. I think what they're referring to is probably the fine sediments. It's called the fines because this is basically the powdery stuff when you grind coffee. You're always going to end up with some of the powdery stuff, and this plunger doesn't have a fine enough filter to filter them out. Even a good filter like paper filters won't do it either. So those are the ones that suspend in water, and very often if you're talking about a dark um, roast, you do end up with chemicals that may be considered carcinogen, but almost every single like roasted, like heated food will have produced some sort of carcinogen. So I would say drink at your own risk. but it's I have not heard that it's harmful, but I do know that there's a bitter layer in the French press.
I was going to make a joke about some people might argue that it's more harmful for me not to have coffee. The risks are greater for my mood.
I actually agree with you on that one.
A couple of questions sort of about the process of brewing coffee. So should you use a paper filter or a metal filter? What is the proportion of grounds to water? Is a burr grinder better?
I use a bird grinder. I think bird grinder gives you better control of coffee grind, and because now I know too much that than I want to about coffee grinds and whatnot. I'm also a little paranoid about the fine powders that generates no matter which grinder that you use. So the grinding is a personal thing in terms of what you like to, or how much you wanted to spend, and what kind of texture you want. So my opinion is I read the reviews and then I find that burp grinder is easier to use and then gives me a little bit more consistent results. So that's grinding. In terms of water to coffee ratio or coffee to water ratio, it depends on the method of brewing that you're using. So, for example, if you're doing a French press, you probably want to do 1 grams of coffee to 15 grams of water. And you will not use boiling water like what we did. We are literally trying to extract every bit of chemicals out of the coffee. But you would probably use about 195 to 200 degree water, maybe a little bit higher, but never boiling. And you will brew about 4 minutes. That's a French press. For a pour over, if you read about pour over, you will see that everybody has a tiny little different way of making pour over. The ratio is again, it's about 1 to 12 or 1 to 15, and some people suggest you put you pour the water in different stages and wait certain amount of time before it finishes. And some people actually stir the grind while you're pouring to make sure that it settles in the bottom rather than on the side. So there are a lot of different ways of doing it. I would say, and this is I talk to baristas, and they very often comment. Their comment is find a way that's consistent for you. You know what you like, and then when you play with all these variables, because it's not a simple variable, it's tons and tons of little things could change the flavor of the coffee. Find something you like and then practice and be consistent, and that's how you would make a good cup of coffee.
So this is going into specifically to the samples that we sent out for those who registered by March 28th. The coffee company, as you know, gave us directions on how to make that coffee into cold brew, but someone's asking, so if they gave us 2 ounces of grounds in the sample pack, how would you recommend converting that into a pot of hot coffee?
Convert the pot of hot coffee?
So if you were going to brew it as hot coffee, and I know I did this myself, so I think so if you don't have a chemical like a chemistry.
Okay, so we were talking. Let me do a slight calculation, and I will The two so 2 ounces of coffee. Um, 2 ounces of coffee is about 56 grams of coffee. So if you're talking about so 56, just to say 60 grams of coffee. So you will probably want to use about. I'm going to do this as a French press for you. So it's about a liter of water, a little bit less than a liter of water. And that is about a liter is a little bit about a quart, if I remember correctly. I have to convert different units right now. I do apologize. Um, 1 liter. So it's about a quart. So the little bottles about so that's how much hot brew coffee you'll be able to produce with that little bag of coffee, which is quite a bit.
Yeah, I did a very unscientific, just use a tablespoon. And I think I got maybe 3 tablespoons, 4 tablespoons, and then
Yeah.
just did, the amount of that, however many tablespoons it was as a
Mhm.
cup of water. And it was pretty tasty. So I enjoyed it. Let's see. Okay. And sorry to make you do math on the spot. I
Oh,
didn't
it's
tell
okay.
you you were going to have to teach a chemistry class. So here's a question. Why is the pH similar if the total acids are lower in cold brew? Do you know of any studies that indicate cold brew causes less acid reflux than hot brew?
Unfortunately, I'm gonna answer the second part of the question first, because the first part is a little bit longer answer than the second part. The study has been inconclusive until very recently because there were no definitive comparisons between hot brew and cold brew coffee. And I do want to clarify that what we studied is the brewing method. So we fixed the amount of water to grind ratio for both hot and cold. And if you're drinking coffee, that's not going to be the case. So there will be slight variation. I have not looked into the literature lately to check if anybody have studied cold brew coffee in terms of acid reflux. So I do not have the knowledge. But in terms of pH and total acidity, pH is a measure of acids that are very that are willing to give off what we call a proton, a H plus ion. That's what pH measures. So lower the pH, more chemicals are willing to give off that proton. But not all acids are willing to give off the proton. So when we measure the total titratable acids, we are actually measuring all the acids in the solution. So what we found out in this particular case is in cold brew, so in hot brew, there are actually acids that are not willing to give off the proton. So there are still acids. So they're still going to behave like acid. They're still going to irritate your stomach if you drink too much of it. So that's why you may have a comparable pH, but quite different total titratable acid.
So we're getting more questions sort of about decaf coffee, and one question that came in earlier was, should we be concerned about any of the chemicals that are being used to make decaf? And then another follow up question that came later was, how much caffeine is removed in decaf? Is it significantly less? And then why is there no such thing as no calf coffee?
Ah, so again, I'm going to answer the second one first because the second one, the limits for decaf coffee in the United States is that you have to remove 97% of the original content. For European Union, that is the caffeine content cannot be more than 0.1% of the dry mass. So the limit is there because total removal of caffeine is going to be quite costly. It is one what we call like approach but never reach, like asymptotic behavior. You can't really get rid of all the caffeine. So the producers and then the processors have learned to optimize the process to reach that limit. So that's why decaf is never completely caffeine free, but has a very low caffeine content. And then the other question about the chemicals that's being used to process the coffee, the number one, they are everything about every chemical is all about dosage, how much you consume. The amount of chemicals that's left in the after decaf is so low. It's about zero point 0.3 milligrams per kilograms of coffee. A kilogram is actually more than 2 pounds, 2.2 pounds of coffee. So it's very minute chemicals left, and you have to drink a lot of coffee to get any kind of effect um, that's due to the solvent used for decaf. So that's number one. Number two, um, only because there are three major processes for decaf coffee, a decaffeination process. You use either solvent, chemical solvent, or you use carbon dioxide, you use water. They are actually equally popular all around the world. So you really don't know which plant is using which unless they spell out explicitly on the label. So it's hard to say whether you are drinking decaf that's being chemically processed or just being extracted with water or carbon dioxide. So that's the answer about decaf.
Awesome. There are so many questions coming in. I'm having a hard
We
time
have
keeping up.
time.
So lots of people want to know sort of how do you make your coffee? What is your favorite bean? How do you make your favorite coffee? What is your favorite coffee? Um,
Okay.
People want to know.
So as I said before, I like a good old pour over, single, just simple um, V-shaped cone, and then put it like about a tablespoon, a little bit more than tablespoon, quite a bit more than tablespoon in the morning because I need my coffee. And then I use 200-degree water, and I make about 12 ounce. It's the size of my cup, and that's what I do pretty much every morning. So it's quick and easy. About 3 minutes, 4 minutes, I'm done. I have my coffee ready. So it's not too scientific because I realize that if I go into my science mode, I'll never finish making coffee in the morning. So it's just better just wing it and then get something decent enough that I could drink. In terms of beans, I do have a preference. I do like medium or light roast beans because I like the flavor in the beans. I am addicted right now to Mexican coffee. They are the roasters I get the coffee from really are local. They took really good care of the beans, and then the flavor is phenomenal, and they are not that expensive. Those are that's my favorite bean right now, and I also like certain Ethiopian beans. Excuse me, and again, it's all about how the roast is being done, and I find darker beans too bitter. I find the lighter beans, especially for Ethiopian, I really like light roast Ethiopian beans. It's nice and citrusy, and then the kind of like fruity flavor that comes through is really nice.
This is an interesting question and that I'm interested to know the answer to because I tend to make a pot of coffee in the morning and let it stay until midday. How long can the coffee stay warm before it starts to deteriorate due to the heat?
Um, the one of the studies, I actually could quote study on this one, and one of the studies tend to suggested that there's really like they put the coffee on the hot plate for 8 hours, and then they find that it was still okay to drink. What people tend to be put off after that long period of time is again the fines, because no matter what filter paper you use, unless you use those really like zero point 0.4 micron, the ones we use to filter coffee for processing, for testing, you're always going to end up with these particles in the coffee. And when you let it sit for a long period of time, that's when over extraction occurs. And that's why your old coffee tastes bitter or tastes like yucky, is because all the bad stuff is coming out of those fine grinds and makes the coffee undrinkable. So if this is what I do when I do make cold brew coffee. Is I actually filter it with double or triple filtered paper. It's going to take a while for it to go through the water the filter, but I let it sit, making sure it catch as much fine particles as possible, and then I could put it in the refrigerator for a week or so with no problem.
That's a great tip. Um, sort of with heat and reprocessing, one question we has is if you're using a percolator, can you re-pour the coffee over the coffee brew over the grinds to get more out of it? Would there be more benefits to that?
Um, you can, but at the same time, you're also extracting chemicals that you may not want to extract because it's not discriminatory. So when you go pour through after you bake the coffee, you pour through again and then have more trying to extract more out of it. Number one, you are extracting all kinds of stuff out of it. So bitter compounds, everything will be, especially percolator has a very high temperature. You really getting everything out of the coffee grind. Number two, there's also what we call the equilibrium effect. At some point, you the solution is saturated. The compounds will no longer come out of the from the solid to the liquid phase. So it it basically you're not gaining much for certain compounds either. So it's double-edged sword, and I would not recommend it.
And I accidentally just dismissed a question, so I'm going to answer it really quickly. Karen asked that the does the company that we sent the samples from have decaf? And I am 99.5% sure that they do. They do sell online, and you can find them at Ninth Street Coffee Company in Philly. Let's see. Oh, is there any concern with reheating coffee in the microwave?
No, I don't think so. Again, if you are having, if you very often when you reheat the coffee, it is the fine particles that you are pretty much over extracting. Some people find it a little bit like yucky when you taste the reheat coffee, but in my family, we reheat coffee all the time. I don't, but my husband does on a regular basis, and then it's fine.
One of our attendees wants to know what kind of sort of roast or coffee bean can they drink to get the ultimate most caffeine? Well, some people are trying to get the decaf. Somebody wants to supercharge it.
Um, So if you don't care about the taste, I would say try a light roast Robusta coffee bean, which is not that easy to find because Robusta definitely has higher caffeine content. And there is a brand that claims to have extremely high caffeine content. Um, I don't know if I'm allowed to say it here or not, but they it's out there, and I would say if you Google like highest caffeine content coffee beans, I'm pretty sure you'll find it. And I have yet to confirm compared to other beans yet, but based on what I read, they're pretty high caffeine. They're pretty caffeinated.
Ultimate. Um, so is there anything sort of that you would say as sort of a wrap up answer to all the sort of questions that have been coming in? Anything that you would say to someone who sort of wants to be their own coffee chemist? Any recommendations for people to learn more about what they're brewing?
I would say there are a lot of knowledge out there. A lot of people have been doing this for a very long time, and you can go online and read about a very specific aspect of coffee in great detail easily. Yesterday, I read a paper on the filters, the pore size of different filters, and then they did all the kind of studies and whatnot on, and it was not, it's really great. So if you wanted to learn about coffee, number one, read up on it. Number two, talk to other people, talk to roasters, and they are passionate about what they do, and they really would love to talk to you about coffee, and they love it, and you will learn more about the different varieties and different roast and different beans from the roasters. And the other thing I would say is don't be afraid to experiment yourself. So the worst thing can happen is to make a bad cup of coffee. But if you experiment yourself and you get to know about what you like about how you prefer, what your preferences, as well as some techniques that can get you to the way you like them. So it's more fun when you get to play with your food that you're eating or drinking.
Wonderful. Well, thank you so much, Dr. Rayo, for spending your time with us and sharing your expertise. To all the questions that came in, I will do my best to get those to Dr. Rayo, and hopefully she can help us answer some of those for you. Thank you for sending those questions in and for being such an engaged audience tonight. I would like to invite you all to join us at a future alumni event here with us online. We have a couple of wonderful ones coming up in the next few weeks and months. And thank you all so much for joining us. Thank you for spending some time with us tonight, and be well and stay safe.